So this is a test of live real-time processing. So there's several items on the screen right now. So we have the left eye, so I close that, the right eye, and you can tell that it looks at my pupil and it tries to measure the pupil dilation. I am using a DSLR camera for this. I'm about, a meter to 2 meters away from the camera, and I have lighting this scene. I get pretty good results with the DSLR camera. Of course, it's not realistic, I think, to deploy a DSLR for this application, and there aren't many other DSLR-like solutions that are affordable. Depending on the cost of this machine we want to build, based on my budget, I decided to go with a parts build that I could afford, that I thought would still approach a good solution. And so I've used in my other demo a device that's $400 or less to manufacture in parts, and that also includes a thermal camera, and it also uses a infrared light source. So with this, I'm using a big bright light source. You can see in my eyes how there's a square. Yeah, it works pretty well. Now, the image is actually much bigger than my face. I'm cropping the image to my face using a face detector. One of the challenges I've run into is the face detector I'm using isn't very good. It detects my face, but it doesn't seem to crop it with consistency. And I haven't really found too many good ones online that are fast and accurate. I'm going to get around that problem by leveraging a web browser. Google Chrome has a embedded face tracker that's very efficient, and my objective there is to use the webcam within a tablet or laptop to track the face, and then to provide that data with the infrared camera's data to whatever servers, so that it can crop accurately that way. There seems to be a lot of advances in that, and I don't really want to have to reinvent the wheel. And by doing it in the browser as well, I can also use the browser to provide guidance and feedback to the user on where to move. So move left, move right, and give real-time feedback to the user on whether they're positioned correctly, and not need to worry about what the infrared smart camera is doing or thinking. There's a green dot in the middle of my head, and this is also part of the face detector, but I'm essentially measuring motion in the forehead with the desire of actually capturing heart rate. So that would be here. And if I pause it for a second, we see that the estimated heart rate is 55 beats per minute. My heart rate does get down to around 60, 65 most days when I'm sitting here, so it's not too far off, but it is not very accurate, because the face detector is low frame rates, and it's also not consistently drawing the square. That square needs to be drawn more consistently. But the code, every time a frame comes in, it updates it. So there's lots of room for improvement on the heart rate detector. But in this real-time application, I'm trying to reuse the face detector for many different purposes, and the frame rate from that is too low. I can fix all that, I believe, by having some sort of queuing buffer, and things that need to pull fast can pull from the buffer, but that's a lot of plumbing that needs to happen, and it wasn't really worth it for what I would consider just a proof of concept at this point. Okay, what else? You can see that my eyes do have enough resolution to get dilation measured. And if I look at my finger here, let's do this. I don't know how accurate that is, but that's example footage of what we'd be seeing. The diameter is not super accurate right now. I need even more resolution, I think, and compared to what this AI model was trained on, it used even closer up croppings of the eye at a higher resolution than I'm capturing, even with this DSLR. So I feel like I would have to move much closer to the camera, or which wouldn't really be necessarily appropriate. Perhaps I would need to capture at 4K resolution. Capturing at 4K resolution also implies that the face detector will move even slower than before. So there's a lot of computational challenges with that. If I want it to be less jumpy. Part of the reason it is jumpy right now is because I am resizing the image before I do the face detector. And so the positioning is kind of in a stepped manner, and so it's not very consistent. So yeah, performance issues are definitely abound. The infrared camera perhaps would be just as good as a DSLR, assuming the lens was in focus. So assuming the person was at the right distance away, and assuming the person was in the right position, essentially. And I can use the webcam to guide the person to stand in the correct spot. And if I capture perhaps, well, I'm not quite sure about height. Someone who is more than a foot difference than my height, they might be out of the view of the camera, and so there might need to be a way to adjust the tablet so that when they are shorter, they have to tilt the tablet down. Just for example, I'm not quite sure how that would be in practice with a laptop hinged display. You can just adjust the laptop, which is how I intend to move forward. I'll just prototype this with a laptop rather than a tablet, and you can just adjust the laptop's hinge, the display to adjust where the camera points. And I'd use the webcam to guide the person to adjust the camera accordingly. I'm not really sure what to do with the glare. That's something I might just have to deal with, but it doesn't seem to affect the tracking too much. And I am able to capture the pupil dilation, but it's not really an accurate measurement at the moment. It's the calibration needs to happen, and that would ideally happen with maybe a 3D model or some sort of I don't know, some sort of calibration system of some sort to accurately dial that in. But it's hard to say. I guess it may not matter if it's all relative in some way to something else. Anyways, so this is an example of the code, the output I'm capturing from the DSLR. I need to provide this. This is a real-time demonstration. I will be trying to pull higher frame rate data from the camera, which I did in some of the videos I uploaded already to the Google Drive, but I need to process those slowly in a batch fashion. So I process every frame and I can hopefully redo this in a higher quality. But what you're seeing right now is why I feel like live processing is not really reasonable. You need high resolution, you need a lot of processing power, and without a lot of optimization work, which is a reasonable ask, but it's not a reasonable ask for someone like me to do all by myself. It would take months for me to, many months probably, for me to get this working smoothly. And so I feel like the first best step would be to focus on video files, processing those afterwards in less than real time, versus this real time scenario, which I just feel doesn't provide good results. It's just, I can't, everything's too erratic, everything's not too low frame rate for me to really offer quality here. Anyways, this is all I wanted to demonstrate, and the code is in the background. There's lots and lots of it, but yeah. Okay, that's the end of that.